Hey, this is Mr. Kelly from Baumholder. We're going to be going through reasoning and proof. We have our three sections here. There's no reason why he should wear this bow tie. I mean, come on. Hello, my name is Mr. Brost. Hello, fantastic. Here's a mastery check. All right, so what we're going to start with, we're going to go through each topic that's on the test. It's going to be a short test, and we're going to get through it here. We're going to start with inductive reasoning. That's like patterns, and so you have to look at the numbers and find a pattern. If the pattern's kind of tricky, I give you more numbers here so you can look at it and make sure that you're right. But the first one here, it looks like it goes down 11 each time, or you subtract 11. So the next two terms there would be negative 12 and then negative 1. How about this one here? It looks like you go up 3, up 1, up 3, up 1, up 3. You have to go, let's see, up 3 and then up 1. That's the pattern. So the next one would be up 1. So the next number or the next term would be 14. And then up 3 will get you to 17. All right, find a counterexample for each statement. I always like to write it out. If you're an algebro, then you're really stinky. I need to find an algebro that's not stinky. And of course, Mr. Kelly, come on. Definitely can't use Sully for that one. If an angle is between 89 and 91, it's a right angle. All right, so counterexample, you have to be between 89 and 91, and then you're a right angle. Well, what if you are 89.5 degrees? That's not a right angle, but that's between 89 and 91. So that would be my counterexample there. And here's where students always get confused. It's tomatoes are vegetables. If you're a tomato, then you're red. Tomatoes are vegetables that are red. If you're a tomato, then you're red. All right, so to find a counterexample, you can't say apple because that's another red. I mean, you're missing the point here. The point is, if you're a tomato, then you're always red. Well, there are green tomatoes. All right, sometimes you fry them. Never had them that way. Green tomato would be the counterexample. If you say apple, then you're wrong. All right, so the next part of the test that we're going to look at, conditional statements and related conditional statements. And so, let's see, you might have to rewrite a sentence, but this one's given to us in conditional form, if-then form. Remember that the first part is called the hypothesis, and the then part is called the conclusion. And the converse is when you switch the two. So you'd have to say if it has exactly 9 sides, then, and you go back to the beginning. So that's what we have right here. The inverse is when you make them both the opposite. So if a polygon is not a nonagon, then it does not have 9 sides. That's what we have for the inverse. In the contrapositive, if a figure doesn't have 9 sides, it's doing both of these actually. You switch it and you negate it. Then it's not a nonagon. So that's easy enough. And then we get to our proofs. Now remember, for proofs, let's look at this here. Take it all in, figure stuff out. They give us 1 is congruent to 6. And they want us to prove 3 is congruent to 7. Okay, so if 1 is congruent to 6, what else do we know? Well, before we get started, let's put that in there. 1 is congruent to 6, and the reason why is given because they gave it to us. Cha-ching. Now I'm going to look at 1 and 6. What else do we know? Well, I know 1 is congruent to 3, so angle 1 is congruent to angle 3. The reason why? Because they're vertical angles. So vertical angles are congruent. And that'll get us 1 is congruent to 3. And the other one they give us is 6 here. So I also know that angle 6 is congruent to angle 7, which is nice because that's where we want to go, angle 7. And it's the same reason. Vertical angles are congruent. And what else do we know? Well, if I do this right, let's see. I'll do it one step at a time, and that means I'm going to need another step here. But if I take the first statement and I take out the 1 because 1 is equal to or congruent to 3, I'm going to put the 3 in. So angle 3 is congruent to angle 6. The reason why? Well, we use substitution. We took out the 1 and we put in a 3 because they were congruent. So that's the substitution property. Awesome. You got to be careful. If you just abbreviate it sub, then someone could think you're talking about subtraction. The last reason that we have here, we have 3 is congruent to 6, but look, 6 is congruent to 7, so I'm going to take out that 6 and put in a 7. So we get angle 3 is congruent to angle 7. and it's for the same reason, substitution property. All right, so that is a geometric proof. Now let's get to our algebraic proofs, where you have to solve the equation based off of all the properties that we have. So remember, we always write the given first, and they gave us this equation, so we write it down, and we need to come up with x equals negative 34. So let's go through. What's the first thing you're going to do? I'd probably do the distributive property. So 4x minus 6 plus 1 equals 29 plus 5x. And that is the distributive property. That's the reason we did that. Distributive property. You write it all out. I'm saving video seconds here. Third, well, I'd probably combine like terms here. Put those two together. So 4x minus 5 equals 29 plus 5x. And the reason why, I'm going to combine like terms. Okay? Next, let's subtract 4x from each side. So minus 5 would equal 29, and then I subtract 4x, that means it's plus 1x, or just x. Let's just write x there. That's going to make our life a little easier if we just write x. The reason why, we subtracted 4x from each side, so that's the subtraction property. Subtraction property. Okay, now what? Let's subtract 29. So we get negative 34 equals x. And that is the same reason, subtraction property. We're almost done because they look close. I'm going to switch the order. X is going to equal negative 34. Why can we switch it? It's the symmetric property. That took a while for me to get it out there. It's like I had to wait for it when I saw it on the screen. Hey, is that it? That is it. That's the review video. Hey, short and sweet, just like the test and the review. Hopefully you'll knock it out of the ballpark. If you study, then I think you'll have no problem. Hey, this is Mr. Kelly Baumholder. Remember, it's nice to be important, more important to be nice. See you.